No, do not want that. Hello. Hey. All right, Skio. So I'm live on Twitch. Oh, you can only do one live at a time, so I can't do live YouTube and live Facebook simultaneously. Oh, all right. Well, it's a start. All right, welcome to my tutoring class tonight, ladies and gentlemen. Welcome. I'm going to give a couple of moments for folks to, if they want to join. Where am I here? Can you see me? Hey. So I am Josh Wiener, and thanks for joining me to study 7th grade math tonight. This video will be recorded on both Twitch and YouTube. They'll be recording, so if you'd like to access the links to the files, like to do a practice quiz, classwork, and homework, the files will be available to you online for free, as I'm offering my course this school year, 2023 to 24, by donation. It's a course that I've personally been putting together for over 10 years, and would like to get it published soon, as it evolves to 100% original class content. Thank you so much for joining me to check out my work as an educator. Quickly about me, I grew up on New York City public schools and was the District 3 winner of Manhattan Athletics in middle school, in 8th grade, I guess, at the center school in their first year. And then I went to Bronx Science, graduated in 4 years with the Regents diploma. And after many years, I completed my college education with a double major in math and Jewish studies. Columbia was interested in me. I went to Columbia Teachers College, where I received a master's in math education. What folks don't know about me is that I spent many years street performing as many years as a juggler and unicyclist and wire walker, and as well as a musician for tips. So most of my earnings, 80% of it, was by donation from street performing, busking around the United States, mostly here in New York, but also I traveled some as a street performer. So that money has been put to good use to my education. And so now as a give back to the community, I'm offering both these courses online by donation. You can give as much as you want. I mean, if you compare my course which goes for $1,500 to $2,000 at tutoring houses, to other courses, you can definitely see that it's a quality class. I recommend $50 a lesson. You can give $1. You can give $100. It's really up to you, because it's by donation. You don't have to give anything at all. You can take the course for free. So again, this is my give back to the community, my SHSAT math class, as well as my SAT math class. So thank you for your support over the years. This will continue to give some good content to my YouTube channel as well, and my new Twitch channel, as I'm learning to stream with the Twitch platform. I'm going to leave the camera off now. Thank you so much. And so what we're going to do is we're going to get started on the class tonight. It's lesson 5, square roots. And as a quick overview of this standardized test, if you're a middle school parent and you're having your child take the specialized high school achievement test, the math section focuses on middle school knowledge of the following topics. There's algebra, geometry, the coordinate plane, charts and graphs, probability and statistics, a few other math topics. The SHSAT math section is 75 minutes total of 57 questions. Starts with 5 written questions in its current form, and then it's followed by 52 multiple choice questions. Tonight, we're going to focus on square roots. Square roots are included in many of the 57 math problems in some form or another, whether it be an algebraic computation of an expression, equation, or a word problem. So keep in mind that this is only one lesson of a 33 lesson set. And this year I'm sharing 25 of my lessons online. to the community. And studying this way for standardized tests is a really important skill for students. If you have, well, no matter what the standardized test is, whether it's a final exam in a college class or the SAT or the graduate record exam, whatever a standardized test is, it has a list, like a checklist of skills that the writers are always testing. So going to a bookstore or an online company and getting a prep book for a specific test that thousands, 10,000s, millions of students take, such as the SHSAT or SAT, is you really have an advantage if you checklist your skills. Okay, this is what I learn as a teacher and at tutoring houses. The more successful students are organized. Okay, so if you're organized with a list of skills that the tutoring house can provide, and you go through their 33 modular lessons, then you're really prepared for 95 to 100% of the questions you'll encounter. Okay, so each lesson has 30 questions in classwork and 30 questions in homework for a total of 60 practice questions. And after you go through the course, if you feel you need more prep time, the way I recommend it is, like, say you're having trouble with anger relationships, lesson 19, and you're like, oh my God, I took that lesson and I only got 5 right out of 30. Well, then we'll give you more worksheets on lesson 19. So with a tutor and guide, we can see your weak areas, scaffold that, meaning support that, and give you just a few more practice problems and do them with you step by step until you can do them independently with mastery. Right? That's the point of being a tutor, to give you the skill so that you can perform them on these standardized assessments. Before we get to tonight's lesson number 5 on square roots, what we do in class is we always warm up our minds to get your mind on math with a quiz. And the quiz contains 2 easy level, 2 mid-level, and 1 challenge level problem. And what I will do is for students in class, I will put the link in chat, but here it is on the screen. If you cut and paste this link or click on the link, depending on your computer screen, it will take you to a Google form with the 5 questions. And I'm going to now cut and paste it and put it in the chat window here in our Zoom room. So if you click on the blue link in the meeting chat, this is quiz number 5. And it's 5 practice questions and 10 minutes. I'm going to take my handy stopwatch timer here, set it for 10 minutes. So if you're watching the video or participating, I will see you again in 10 minutes and we'll review these 5 questions. So welcome to SHSAT class, and here's our warm-up quiz. Please click on the form and we'll begin now, and I'll see you in 10 minutes. Good luck. Just 2 more minutes on tonight's quiz. 2 more minutes on SHSAT quiz number 5. All right, that's time for SHSAT quiz number 5. 5 practice questions in 10 minutes. So please scroll down to the bottom of the Google form, and then you'll see a bubble sheet for you to bubble in your answers for the quiz. Make your final selections for questions 1 to 4, and also for the grid-in question, question number 5. After you finish completing the form with your name and email, then click on the blue button below or submit, and the form should auto grade for you, giving you a score of 0 to 5. And what we'll do now is, as you're wrapping up and submitting the form, we're going to go over each of the questions, and I will give you a method of solving each question in less than 2 minutes. Here's question number 1. Question number 1 reads, a school photo company sells their photos in 3 sizes. You can get 1.5 inch by 2.5 inch height. You could get the 3 by 5, or you could get the, how am I going to fit this on the screen? I guess I have to do it lengthwise. 3 by 5, I can't. 9 by 12 would be like that. So here are the 3 sizes for the photos, but this one's turned 90 degrees. So for example, if we're to draw it, can I just say 2 minutes? Or we're to draw the photo like this, and here's your school photo. Then this would be facing, I guess, this way. All right, so how do we figure out the ratio between the heights? Well, the heights are 2.5 to 5 to 12.0. So that would be, this side is 2.5, this edge is 5, and this long edge is 12.0. So what in the world, what can we do for to figure out the ratio between all 3? So it has to be equivalent to one of the ones above, but notice that there are some integers, if you look carefully here. You can see 2, 1, 1 in second place. You can see a 4. So why don't we take these 3 measurements, which were given in blue. We have a 2.5 is to 5.0 is to 12.0. And It doesn't look like if we divide by 5 that we'll get the middle column will line up with, because then if we divide this by 5, it'll be some strange decimal. Divide this by 5, it won't be an integer. Let's double it. So let's do times 2. So I'm going to take each number and do times 2, and we get 5, 10, and 24. Looking across, it looks like D is correct. We have 5 is to 10 is to 24 is the correct ratio. All we have to do is we have to just take those measurements and divide each one by 10, and we'll get the correct ratio, 1/2 to 1 to 2.4. And the correct answer was D. That was number 1. Question number 2. Compute the exponent a to the power of b minus 1 minus b to the power of a when a is given the value of 2 and b is given the value of 7. Just be careful plugging in here. The base of the exponent is 2, and the exponent itself is 7 minus 1 is 6. And then the base of this exponent is 7, and the exponent is 2. 2 to the 6th power is 2, 4, 8, 16, 32, 64. You can try that yourself. Minus 49. One way of doing that, if I did that too fast, 2 to the 6th is 2 times 2 times 2 times 2 times 2 times 2, 6 times. So maybe if I group them into triplets, 2 times 2 is 4 times 2 is 8. So there are these 3. 2 times 2 is 4 times 2 is 8. Then 8 times 8 is 64. Okay, so by regrouping the exponents, you can calculate them faster. Finally, 64 minus 49, well, stack them. 64 minus 49. 9 is bigger than 4, so borrow from the 10s. That's a 5. That's now 14. We get 5. 15 is the difference. The correct answer was E. E, 15. For question number 2. Question number 3. Devin completed 5 exams and scored 80, 75, 82, 91, 95. What score does Devin need on the 6th exam to have a course average of 85? Well, I'm going to show you an unconventional way to figure this out. And it's since we're given the goal here is to get an 85 average. So she wants an average, she or he. I'll say, let's pretend it's she. Okay. So then what did she get? So far, she's got an 80, that's below. Then she got a 75, that's below the average she wants. And she got an 82. But then look, she had 2 really good grades. She had a 91 and a 95. So she got 3 below the average that she wants. This is her average, that goal. So let's count the number of points below. When she got an 80, that's 5 less than her goal. When she got a 75, that's 10 less than her goal. When she got an 82, that's 3 less than her goal. However, when she got a 91, that's 6 more than her goal. When she got a 95, that was 10 points above her goal. And then, believe it or not, this is how you do it. You count the positives. She got 16 points above the average she wants, but she's also got 18 points less. So she has 2 points below her average if they were all 85s, right? That's 5 below what? 85. That's 10 below 85. That's 3 below 85. That's 6 above 85. That's 10 above 85. So she needs one more grade, and it has to be an 87 so that she gets a +2. So it averages out to 85. If this is a new way of solving it, then I've showed you a new method. This always works if you're given the goal average. And check it out. It really works. So then take the 6 numbers and you can check yourself. You have to add them up and divide by 6, which I'll do on the right side of the screen. We can do that. All right. And then we have, I'll type it out nice and neat. So 80 plus 75 plus 82 is going to be added together. And 8 plus 8 plus 8 is 240. So it's 237. And then she got 91 plus a 95 plus an 87. Adding just the tens column, 9 plus 9 is 18 plus 9 is 27, but it's one less, so it's 260. Plus 12, 272, 273. Then adding all 6 together, we get a 510. Okay, I just carry, and I do it a little bit fast, but you can check the math. So she's earned 510 points total. But we have to divide that by 6. So 510 divided by 6 is 8 times 6 is 48. Subtract, we got 30, and it's 85, which was exactly what Devin wanted. So the last exam, she needed just 2 more points above the average, or an 87, to balance that out, as if she had 6 85 grades, or an average of 85. Okay. Number 4, if an edge of a cube is increased by 2 inches, then this is tricky. Well, let's read what they say. They say the volume is increased by 8, the area of each face is increased by 4, the diagonal of each face is increased by 2, the sum of the edges is increased by 24, surface area is increased by 24. All right, so let's pretend this is the unit cube. Maybe it's, say, 10 by 10. But now we're going to expand it, so it doesn't really matter, but from the corner, another 2 units. And then from this corner, this edge, another 2 units, and also the height. So the length, width, and height, we're extending another 2 units. So can you see these connector rods? Well, I'll make it a wireframe. It's really 4 in the front, which is represented by this red square. There's 4 rods in the back, 4 edges in the back. That's 4 and 4 is 8 edges. And then there's the 4 connector rods, which are here. 1, 2, 3, 4. Okay, so there are 12 edges. And each is getting a +2. Each of the red lines is going to be 2 units longer along those green arrow vectors, the length, width, and height. So that means all of the edges together, 2 times 12, will be increased by 24. The correct answer is D is correct. Should be green for correct. Okay, some trick answers here. A is wrong because the volume is increased by 8. No, that would be 2 times 2 times 2 is 8. So no, if you do 10 cubed, then and increase by 2, then 12 cubed is much larger than that. Just try a number and then adjust it, or try even a 5 by 5 by 5 cube. If you make it 7 times 7 times 7, that's more than 8 increase. The area of each face is increased by 4. No, because the face is the front. So say it's a 5 by 5 cube. The face, this area would be 25. If you increase it by 2, then the area of each face would be 49. So that's also, you can just do that by counterexample. The diagonal of each face is increased by 2. Well, if that's 5 and 5, then the diagonal is 5 root 2. It's side root 2, based on the Pythagorean theorem. So no, that's not being increased by 2. The surface area is increased by 24. No, because each face is increased by more than 4. It doesn't have to be 4. So the correct answer by elimination also is D. The edges, those red connector pieces, if we were to put them together, there's 12 of them to make a cube. And that would be increased by 24. All right, I think 3D geometry was new for a lot of 7th graders this year. The world record for cycling a stretch of 20 kilometers is 26 minutes. This corresponds to an average speed of approximately how many miles per hour, rounded to the nearest mile? But a mile is 1.609 kilometers. Well, here we go. Based on what's given, we're starting with 20 kilometers upon 26 minutes. But we want to convert this measurement using our conversion blocks. So I'll write them in white. We want to convert it to like this. Then we'll convert it with another conversion block to, let's see, we need to convert it to hours, and we also need to convert it miles and hours, right? We want miles per hour. So let me put what the goal is on the right side. So the goal is the unit should be miles and hours. So the first block will convert it to miles because we're in minutes. And the second white block will convert it to hours, right? So how do we convert it to miles? Well, we have to use the given here, 1 mile is 1.609 kilometers. So we set up the fraction with the numerator and denominator. Note that kilometers is in the numerator, so we want kilometers in the denominator, and because we want miles in the numerator. So that is the correct setup here. So we have 1 mile and 1.609 kilometers. And then, we have to do one more conversion. We have to do hours instead of minutes. So we want hours in the denominator. Minutes is in the denominator, so we need to put in the minutes in the numerator to cancel. So let's make sure that you understand that concept. I'll underline it here. Kilometers is here, so we want to eliminate it. So you have to have kilometers on the other side of the fraction to eliminate it. Minutes is in the denominator here. So we need it in the numerator so that that unit eliminates as well. And then we're good to go. Once we set up the fractions, we'll have miles per hour. Oh, I forgot the numbers. How many minutes are in an hour? How many minutes are in an hour? You said 60 minutes is 1 hour. That's the correct setup for the conversion fraction. So we have 2 conversion blocks here. What we have to do is we just have to go across and multiply 20 times 1 times 60 and 26 times 1.609 times 1. Is there any weird factoring we can do? So if we do this, if you crunch the numbers, can we eliminate anything? Well, I guess we could reduce it a little bit. So let's make this a 10, make this a 13. Then we have 10 times 1 is 10 times 60 is that'd be 600 miles. And then 13 times 1.609, gosh, 13 times 1.609 is 20.917. Let me write this out because it's kind of important here when you're doing that. 20.917. All right, we have to round to the nearest mile. Since it's 20.917, what we can do is we need to divide. This is weird. We need to divide 600, and I'll put some zeros down here, by 20.9. Okay, that should be good enough because we're rounding to the nearest mile. Okay, so 2.09, we'll move the decimal 1 over. 209 divided into 600, that will go twice. 2 times 209 is 418. Subtract, and we get 182. This is not an easy one. Bring down the 0. Okay, so since it 209 times, maybe I should do the times table for 209. 209 is the first one. The second one is 418. And then this is a math trick to doing this a little faster. Fourth one would be double that. So that'd be 836. And the 8th multiple would be 1672. And if we add another 200, that will be too high. So I know it's 8. Okay, so I'm not doing the entire times table 1 to 9. I'm just doing 1, 2, 4, and 8 to get a sense of what number belongs there. So it should be this one, 1672. All right, 0 from 2, that's 8. I borrowed, so now it's a 1, that's a 4. I borrowed, that's 148. Yeah, that's it. Bring down the 0. Looking at the table again, it can't be 8 because that's 1672. That's too big now. So maybe 7. Yeah, 7 should work. Yeah, 7 will definitely work. 7 times 2 is 14. And 7 times 9 is 63. 1463. Okay, let's stop. Because it's 28.7 something something something. We'll round up, and the correct answer certainly was 29 miles per hour. Wow, for going that speed on a bicycle, human-powered bicycle, for 26 minutes. That's going 20 miles per hour on a bicycle. So really strong legs, really strong, good breathing. Wow. Okay, so that was the world record for human bicycling. 20 kilometers was done in 26 minutes. Almost 30 miles, 29 miles per hour. All right, that's it for the quiz. All right, so notice the challenge level had 2 conversion steps. You had to know your units, you use what's given, and you had to know how to simplify it with a few different math skills to get the right answer. And I think that took about 3 minutes to do the challenge problem. Okay, so let's go to the lesson tonight. We're going to focus on square roots. And here we go. So SHSAT lesson number 5. A square root is the length of the side of a square. If, for example, if a square is an area equal to 25 square units, the length of the side of the square is 5 units. It's good to know your squares up to 20 squared for the SHSAT. Most problems in the middle and high school math use squares from 1 to 10, but this test often makes work of a little more challenging for the learner by including the list up to 20. So in this problem set here, I'll circle it so you get the idea. You know that 1 squared is 1. For example, most folks know that 5 times 5 is 25. And even though there's squares up to 100, and that's good. But for the SHSAT, you should know your squares up to 20. 20 times 20 is 400. So the perfect squares from 1 to 20 would be good to know for this exam. Once you know your squares, the inverse operation of squaring n is to take the square root of a number. This list has a special place, has spaces between the natural numbers, so this skips between the perfect squares. They increase by odd values. Why did I say that? All right, so the square here I'll write with an arrow. No, square root of 1 is 1. The square root of 4 is 2. We know this from work. The square root of 9 is 3. The square root of 16 is 4. Safe to say the square root of 25 is 5. The square root of 36 is 6. The square root of 49 is 7, and so on. However, what's sometimes a question on the SAT is, well, look at the difference between 1 and 4. You have to add 3. To get from 4 to 9, we have to add 5. To get to the next square, you have to add 7. To get to the next square, you have to add 9. And this is not completely secret knowledge. It's called the Neumann growth, which we go over that some other time. It goes up by the odd numbers, growing squares, growing up. It says from this list, we know that the square roots that are perfect squares, such as, we know that the square root of 4 is exactly 2 on the side of the square. The square root of 100 is a 10 by 10 square. The square root of 361 is 19 because it's a 19 by 19 square. These values of n have square roots that are whole number values. Well, what if it is not a perfect square number? Then we want to know what 2 whole numbers is the positive square root close to. For example, the square root of 10. We want to know what the side length of the square is. If the square is 10, this is here. We already know the perfect squares that it's in between. So we know it's in between 9 and 16 because 10 is bigger than 9 and less than 16. But lo and behold, we already know that the square root of 9 is 3. We already know the square root of 16 is 4. So even though we might not know the value of the square root of 10 exactly, it's somewhere between 3 and 4. Similarly, for the square root of 67, the square root of 64 is 8. The square root of 81 is 9. So the square root of 67 is a number between 8 and 9. Looks like it's closer to 8 in this example. Also, the square root of 169 is 13. The square root of 196 is 14. So the square root of 173 is a value between 13 and 14. Here's a geometric representation of what I just said. It also helps to know that radicals that are not perfect squares can be approximated with these known perfect squares. Here we can see by the drawing that there are 16 boxes if the area, a square with area 16 has a square root of exactly 4 on the side. 4 times 4 is 16. On the right, you can see that the area square on the right has an area of 25. There's 5 units on each side for an area of 25 units. Well, what if we want to work out the area is exactly 20? Well, that has to be some number between 4 and 5. And what we can do is we can use the square root of 20 here. You can see that it is 4.47. So you have to sit there and try a tens first, like do 4.4 times 4.4. You see that's a little bit less than 20. And then 4.5 times 4.5 is a little more than 20. And so we know that approximately it's some number between those tenths. And then you can try the hundredths. The other reason that we need to know our square roots in solving problems faster and saving time on a time test is you should use estimation for measurements. For example, if the problem says it's the square root of 24, well, that's very, very close to the square root of 25, which is 5. So use 5 as an estimate in the problem. For the square root of 120, for example, that's very close to square root of 121, which is exactly 11. Because 11 times 11 is 121. So if the problem says the square root of 120, you can use 11 as a good estimate in the problem. Although classroom lessons have square roots that are usually measured from 1 to 100, it's not uncommon to see 3-digit square roots on the SHSAT. For example, root 400 minus root 289 could be the problem, and you'd have to figure out that that's 20 minus 17, which is 3. The square root of 225 minus the square root of 36. Well, that's 15 minus 6, which is 9. And finally, adding square roots, well, the square root of 16 plus the square root of 49, well, that's 4 plus 7, which is 11. You need to be able to work those out with pen and paper. Radicals can also be multiplied and divided. Here you can see that the square root of a times the square root of b is the square root of a times b. So for example, root 6 times root 2 is then 6 times 2 or 12. Root 2 times root 3 is root 6. But interesting here is that root 6 times 2, that's 12, times 3 is 36. Those 3 irrationals form a perfect square, which is 6. Similarly, the square root of a ratio, a over b, is the same as the square of the numerator over the square of the denominator. For example, if we want the square root of 16 over 9, well, that's certainly not a whole number. It's a number between 1 and 2. But if we split it into the numerator and the denominator, the square root of 16 is 4, and the square root of 9 is 3. So it's exactly 4/3. Right. Tonight, we're going to go over the classwork problems. These worksheets have 30 problems total, and the first 12 are easy level, the next 6 are mid-level, the last 6 are challenge level, and then it ends with the 6 gridding questions that are cumulative review of the course from lessons 1 to 5. So what I'd like you to do is click on the form link here if you're participating tonight, or if you're watching the recording, this link will still be active. And you too can try the worksheet on square roots, which includes easy, mid, and challenge level problems. Since it's only a 90-minute class, we always only do half of the problems. So since it's an odd lesson number 5 in this year cycle, we're just going to do the odd problems. So odd number problems. So we'll be doing 15 of the 30 problems for a 20-minute practice. Okay, so you'll notice that the easy level questions, maybe you can do in 15 seconds, 30 seconds. But as you get to the mid and challenge level question, they'll take a little bit more time. But that is all the time we have when we have a timed class that has to end in 90 minutes and we need time to review. So please click on the form link. And again, I take a moment to, if you can and like to support this course, please go to Venmo Joshua Wiener 10. And I'm thankful for your donations. So good luck on SHSAT quiz classwork number 5. Focus on square roots problems on the SHSAT. Good luck. See you in 20 minutes. Just 3 more minutes on tonight's practice of square roots, SHSAT lesson 5. 3 more minutes. Okay, so that is time for our wow, echo, for our practice tonight for SHSAT classwork number 5. That was a full 20 minutes practice, and now what I'd like to do is go over the problems, a few select problems one at a time. Before we do that, sorry, I neglected to do something here that I'd love to do for you. So you give me just a moment before we go to the questions set. I will I'd like to present to you the answer key to the problem. So if you give me just a couple of minutes, I just want to double check the form to make sure that all of the answers are correct here. Okay, just double checking. So I'll be with you in just a moment. All right, so if you give me just a moment here as I refresh the form, I just made a couple of corrections on the slideshow presentation here on SHSAT number 5, square roots. And as we go through the form here, I'm proud to present to you the solutions to the classwork. You can see here that just reading them tonight, since we're only doing the odd number problems, 1 was D, 3 was D, 5 was A, 7 was C, 9 was B, 11 was D, 13 was C, 15 was A, 17 was A, 19 was B, 21 was B, 23 was C, 25, 12, 27, 168, and 29 was 4. So please check your answers. And if you submitted the Google form, it of course auto-graded it for you, but here is the an array of the 30 questions with solutions to classwork so that you can study the similar questions and then attempt the homework problem 30 set. Okay, so let's go over a few of the problems here. I have a slide for each of them from 1 to 30, and I'll just select a few from the easy, mid, and challenge level. For example, question number 1. We have the square root of 225, and it ends in a 5. So knowing the number patterns, well, it's bigger than 10 because 10 times 10 is 100. Indeed, it is 15. If you need to check that, you quickly go to your side margin and you do 15 times 15, put down the 5, carry the 2, 7, put down a placeholder, 15, and add. And sure enough, 225 is a perfect square. It's 15 times 15. You should know the square root of 36 is 6 times 6. And then adding those two square roots, that's really 15 plus 6 is 21 units total. The correct answer is 21. For question number 3, this is where we're talking about the quotient of in a square root. You split it into the numerator and denominator. So here we have the square root of 9 up in the numerator and the square root of 16. Makes the problem much easier. Simplify the numerator, that's 3. Simplify the denominator, that's 4. And the correct answer to number 3 was D. 3/4 is the square root of 3 squared over 16. Question number 5. If n is root 32 plus root 53, then n is a number between 9 and 10, 10, 11, 11, 12, 12, and 13, or exactly 13. Well, let's see, 32 plus 53 is 80 in the 85. So you have to know your square roots. 1, 4, 9, 16, 25, or it's not in the first 5, 36, 49, 64, 81, 100. Oh, okay. So it's between 81 and 100 because it's 85. So root 81 is less than the root of 85 is less than the root of 100, right? Those measurements. But we know that these are our landmark square roots. They're perfect squares. We know the square root of 81 is a perfect square, and that is a perfect square. 9, yes. Square root of 100 is 10. So the square root of 85, which seems a little bit closer to 9, maybe 9.2 or 9.3, 9.12 or 3. Well, the point is that in terms of the English expressions above, A is correct. It is some number, some distance we would measure between 9 and 10 units. Correct answer is A. Question 7 is similar to number 5, so I'm not going to go over that one. Question 9 is another great question where you can see that you have irrational numbers and they combine to back to the integer set. So here, if we have a square, let me draw it as a rectangle, and just so you get the idea. All right, if we have 2 square root 8s, that means like that's the square root of 8, that's the square root of 8. And then square root of 2 is much shorter, right? So we have the square root of 2, 3 of them. So what we're saying is we want the area of the rectangle that's formed when you multiply 2 root 8s on this side and 3 root 2. Well, what's the area? Well, you just multiply them. 3 times 2 times root 8 times root 2. We can combine these. 8 times 2 is 16. 3 times 2 times 4. 6 times 4 is 24 units. So even though the side lengths are not integers or decimals, they're rational numbers, the total area, multiplying them together, is precisely 24 units. The correct answer was B. So that rectangle has an area of 24. Question 11 is kind of elementary. That's an easy level. Question 13. For how many positive integers is the square root of 80 less than n? All right, again, you have to know this set. 1, 4, 9, 16, 25, 36, 49, 64, 81. Wait, stop. Because it's the square root of 80. So the square root of 81 is 9. So since it's all this set, so 1 up to 8. So there are 8 positive numbers. If you take the square root, it will be less than the square root of 81. Correct answer is C, 8. All right, the wording is just strange because the arrow's on the right side. But square root of 80 is larger than that set, so just be careful. Caution orange. That means that it's all these guys are less. And if n is 8, 7, 6, 5, 4, then it's less than what we see here. The square root of 80 is the right. The square root of 80 is here. Okay. Square root of 81 is 9. So any numbers 1 to 8 will be less than it. All right. 15 is fun too, because it's like the other one that we did with the rectangle, but now we're multiplying 3 measurements. Well, what's so hard about that? We're going to do 4 root 6s. 1, 2, 3, 4. Let's pretend it's that. And then 2 root 2s, maybe like that. And then a depth of 3 root 3. So let me draw it like this, like a pencil box. I'm going to draw the connectors. Should look like a rectangle prism. But the idea here is going to a corner and projecting out from a cornerstone. This is 4 root 6 in this direction. The height I said was 2 root 2, and this is 3 root 3. 4 root 6. 2 root 2 and 3 root 3. So when you do the volume, that's length times width times height in 3-dimensional geometry. So let's put the group-like terms. 2 times 3 times 4 times root 2 times root 3 times root 6. Well, let's do the rationals together. 2 times 3 is 6 times 6 is square root of 36. That is now a perfect square. So that's 6. 2 times 3 is 6 times 4 is 24. 24 times 6. Wow, not that easy. All right, I'll double it. 48, and I'll do this 1 times a half times 3. 144. Correct answer was A. So amazingly, that rectangle prism has an integer value in the solution. The volume, the total volume, is exactly 144 units. Say it was my pencil box, and with my various pencils and erasers and whatever is safely tucked in my box, in my pencil box. Well, the dimensions are, for this pencil box, 4 root 6, 3 root 3 on the long bottom, but a height of 2 root 2. The end. Right, interesting. All right, 17 was another good one to go over. Okay, root 2 plus root 2 is now squared. Well, we have 2 of these things. We have 2 root 2s, and we're squaring it. This is where students got lost. They go, I don't get it. Well, if we had 3 plus 3, that would be 6. If we had 5 plus 5, that'd be 10. We have 2 3s, 2 5s. Here we have 2 of these square root 2s, and we're squaring it. So we're multiplying it by itself. So 2 root 2 times 2 root 2. So that's 4 times root 4. Is 4 times 2 is 8. This one is more fun to draw. This one was fun to draw in class. Show you why. root 2, root 2, root 2, root 2. It's a square. But check it out. It's a giant square. It's made up of these four things. So if this is the square root of 2 and this is the square root of 2, that's 2 root 2. This is the square root of 2. This is the square root of 2. Yeah, what's wrong with the pen? This is the square root of 2, and this is the square root of 2. Well, that's the length and the height. So that means that the area here is the square root of 4, but that's equal to 2. So that's also 2, that's also 2, and that's also 2. So the total area is 2, 4, 6, 8. And it checks out if you draw it geometrically. Okay, that's root 2 on that side, plus root 2 on 2 root 2. So you can actually draw it out and then do the products of each of the rectangles that are formed. Here they're actually squares because they're the same value. Done. Let's go to the advanced problems. 21 maybe? No, it's not that hard. 23, that's not hard. 25 is similar. All right, let's go to 23 because we didn't do a scientific notation yet. All right, so this was on the challenge problem page. You had to be familiar with scientific notation. So if we have 5.835 and it's times 10 to the 4th, you have to move the decimal like I'll draw it like a streamer underneath 1, 2, 3, 4 places. So we get 58,350 and stop. So that's equivalent. Similarly, 1123 times 10 to the 4th. Well, the decimals here 1, 2, 3, and we also need a extra 0 here as well. So that's 11,230. So they are in the tens of thousands. Why are they both in the tens of thousands? Because 10 to the 4th. So that's scientific notation, which we will focus on in a week or two here when we do algebra. We'll have a full lesson on this, but so this is sort of a predictive question, meaning it's a little bit ahead in the course. You haven't seen this notation, science notation. So scientist looks at measurement 1 and says, oh, we're in the 10,000s. 5 times 10,000, 5 and a little more. This is it's a little more than 10,000. And sure enough, it's 5 times 10 is 50. We're in the 58,000 or 58,000 and a little more. There's 11,000 a little more units. Okay, so scientists at a glance can see what by the power level, right? The magnitude of the number. Wait, it's C, it's not D. Why did I highlight D? What am I doing? No, D is wrong. E is wrong. It's C. 58,000, I just said. 350 plus 11,123. The end. Okay, on to the grid-ins. That one was 12, that one was 27's weird. 27's weird. Okay, last two for tonight. 27 and 29, excuse me. 27 was mid-level. It says, let R equal 8 times 9 times 7 times 13. Let S equal 4 times 6 times 11 times 49. What is the greatest common factor of R and S? Well, R is a monster number. It's humongous. We're not going to calculate it. But it is 8, which is 2 times 2 times 2. 9 is 3 times 3 times 7 times 13. We're not going to multiply it. Like 72 times 7 is 490. 504, right? 504 times 13. Oh, it's like 6,500. It's like it's in almost 10,000. S 4 times 6. 4 is 2 times 2. This is 2 times 3 times 11 times 7 times 7. What do? We find the ones that are on both rows. There's 3 2's in common. Looks like, here I'll use a different color. There's a 3 in common. I'll use the wire circle. There's a 3 in common. There's a 7 in common. That's it. 2, 2, 2, 3, and 7. So the common factors What do they have in common? These monster large numbers in their prime compositions. The greatest common factor, they both have these elements. It is, put it on a list. Dun, dun, dun. 2 times 2 times 2 times 3 times 7. Right? That both numbers have these 5 primes in the prime composition. 2 times 2 times 2 is 8 times 3 times 7. All right, so now let's crunch the numbers here. That's equal to 8 times 3 times 7. It's the easiest way to do this. Do the large numbers, maybe. 8 times 7 is 56. Times 3 is, right? Now I'm using distribution. 3 times 5 is 150. This is in the tens column. Then 3 times 6 is 18. And finally, we get the GCF is 168. If you put 168, you have the correct answer for number 27. What does that mean? It means whatever the monster number R is, that's in the 6,000 or 7,000, and whatever the giant number S is, if I round that to 50, 50 times 10 is 500 times 24 is 12,000. That one's above 10,000, right? The largest number that divides R and S is the number 168, because all 5 of those elements are in R, and all five of those primes are in the giant number that is S. All right, last one for tonight, number 29. For how many positive integer values of n will the expression 18 over n plus 2 be an integer? That. All right, so n is positive. So n could be 1 or 2 or 3 or 4 or 5 or 6. Let's see what happens. If n is 1, then we'll have 18 upon 3. That's 6. That's an integer. So 1 works. If n is 2, we have 18 over 4. 4 does not divide 18. So no. N is 3. We have 18 over 5. 5 does not divide it. It's got a remainder 3. No. So what I'm looking for is I want to place a number on the bottom that's good, that is some divisor of 18. Well, I know 4 isn't. I know 5 isn't. I think 6 is good, though, because 18 is on the 6 times table, right? You see, I'm doing this methodically. I don't know why I chose blue, though. I'm going to switch to yellow chalk. 18 over 6 is good because 6 divides 18. Well, then I think, well, 7's no good. That's not on the 18 is not on the 7 times table nor the 8 times table, but 9 divides 18. All right, so I need 1. I need 2 less. I need it's tricky. So I need 4. 1 works, 4 works, because 4 plus 2 is 6. 9 works, which was 7, because we're adding 2 to it. All right, and then 10 won't work. 18 is on the 10 times table, 11, 12, no, because it'll be 1.5, 13, 14. So if you go to the next one will be 18. None of the numbers there are on the 18 is not on that times table. So then 16, then that will equal 1. So since it has to be an integer, there are the solutions: 1, 4, 7, and 16. Those are the only ones that will denominators where 18 is on that times table. There are only 4 solutions. I'll say it one more time. 18 is on the 3 times table, so that it works. We get the whole number 6. 18 is on the 6 times table, so we get the integer 3. 18 is on the 9 times table, so we get the integer 2. 18 is on the 18 times table, so we get the integer solution 1. Here are the solutions one more time. Dun, 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 dun. 6. 18 out of 6 is 3. The integer 3. That's good. 2. 1. Can't get less than 1 with their integers. 4 and 5 didn't work out because 18 isn't divisible by 4 or 5. Yeah, that's fine. It's on the 4 times table of 5. All right, that's it. Now, let me go backwards. Why can't we use 2? Well, we can't use 2 because we have to plug in positive integers. We're adding 2. So if we plug in 0, that's not positive. 0 plus 2 would give us 2. So we have to stop there. That's the first one we can try. It's n equals 1. It has to be plus, it has to be positive. And that gives us a 3. All right, that was challenge problem number 29. So there are only 4 solutions. So if you said, oh, what about 18 divided by 1, 18 divided by 2, and you said 6, 6 is incorrect. 5 or 6, that is wrong. 0 over counting. Can't count those first 2. Okay, interesting series, interesting set, a finite set. We're done. All right, I hope that you've enjoyed this tour of the wacky and fun problem-solving problems of the SHSAT. Notice that a lot of the problems we went over are a little different than normal math homework. They're more, you have to give it a little bit more thought. They're more like puzzles or logic or combining lessons on this specific test. If you'd like further information, I would definitely, to get ready for your child to get ready for the SHSAT, if your school has a math team, mathletics or AMC math contests, go get the contest from a middle school math contest. Go get books from like Dean Posmentier from CCNY, Theoni Pappas, Martin Gardner. These are the famous math writers for recreational mathematics. Go to the AMC website, look up the exam AMC 8, which is very similar to the SHSAT. I thank you so much for joining me tonight. My name is Josh Wiener, and I'm the head of JW Test Prep and Tutor. I've tutored students for the SHSAT, SAT, ACT, PSAT, the test for high school, Catholic high school admission, the cooperative exam, AP exams in calculus, statistics, and the sciences, the graduate record exam, as well as gotten students to do well on exams for nursing school, medical school, business school, graduate school, and doctoral programs. So it's been a fun journey as a tutor, doing everything from grade 5 up to graduate school level math with my students. That's my website, JW2542 Wix, if you'd like to know more about me and see parent praise for my tutoring, working with children one-on-one. I am for hire. If you're interested in having me be your personal tutor, please email me at JSMW2542 at gmail.com or call me at the number on the screen. Again, I thank you for your kind donations, as this is promoting my my tutoring work, as well as helping me develop as a teacher and tutor and educator. And so this course is free online. It'll be posted on both Twitch and YouTube, so you can review it and you can access the forms here at any time. I'll leave them open form as a free pedagogical access for you. If you're getting ready for the SHSAT, use my class, use my course. If you're having trouble with the forms, I'll make sure that I send you fresh links so that they work, or direct you to my Wix site where I'll try and set up the whole set for you guys, or set up on WordPress. Okay, in the future, I may monetize it. I'll try and do it as a Patreon class or as a GoDaddy or another class. But I thank you so much for joining me tonight for lesson number 5. It's been a long, long journey as first a performer and as an educator for over 15 years for my career. So thank you so much. Thank you so much. And I will get to all 25 lessons this year. The other thing is that next week we'll meet on October 18th at 7 p.m. if you'd like to join me. Thank you so much for being here tonight and for checking me out. So again, it'll be posted on YouTube and on Twitch. And have a good night. And thanks for studying a little bit of math with me. And happy studying. Bye-bye.